Today we're going to be looking at some more hacks, so let's get started with some scientific experiments. Again, I'll just be explaining this. This will be a very quick, we'll do this one. We'll make it so it is a about 15-16 minute video, so you don't need to hear that. That's not really important. But what we're going to be doing is explaining all this, and if it doesn't seem right, I'm going to call it out. The way that works is he's probably using some liquid nitrogen, which is one of the coldest things. It could also be liquid hydrogen, but I would highly doubt that, since that's kind of rare. And it freezes things instantly. It's also how you can make instant ice cream. Remember, do not try any of these at home. Well, you could. You could try these at home. Maybe. I'll tell you if you can't. Or it wouldn't be a good idea. You guys saw this in our last video, except instead of shaving cream, they used whipped cream. It's just because of the density, it takes a little bit to go through, and then it just turns into food coloring, so, yeah. Basically just gives it a delay. Huh. Okay, so one of two things could have happened there. A, what could have happened is the room was very, very, very cold, so the water instantly froze. Actually, there are three things that could have happened. It also could have been dry ice that was under it, therefore it would also freeze instantly. Or it could have just been liquid nitrogen again. So, again, that's insanely cold, so it could have been that also. The way that works is because, think of this, if you have clean water, like with no salt, no minerals, no nothing in it, just plain water, the things will mix into it because most things would be heavier than regular water, correct? So, if you were to add something like salt or sugar to the mixture, like they did right here, it would make it so the sugar would be on the bottom right here, but because the food coloring would actually be lighter and have less mass, it would stay at the top. So, that's how that works. The reason that worked was because if you add ice, like to your driveway, you add the salt if you have an icy driveway or something. By the way, I'm trying to make this a little bit more simple for everyone. That's why it's taken me a second to think about it. Since I understand the scientific version, but if I try and make it easier, it's easier. So, basically what happens is, as you can see, it freezes to the bottom because the salt is basically melting down the ice to a certain temperature and there's water on the bottom. The actual coldness, because as you might know, heat rises, which means the cold is stuck at the bottom, so it would actually take the heat out of the water in the bottom and freeze it just a little bit. Now that is interesting because as you guys might have seen in your kitchen or anything like that, you would have seen that oil and water do not react because one of them has a higher surface tension than the other. And I believe that that's oil. I could be wrong. Could have been the opposite. So they don't react very well to each other. So they can't mix. So instead of the water or the ice melting and having the water to go to the top, because the surface density and the mass of the baby oil and vegetable oil, it'll actually go down because it's not it's more dense or less dense or whatever. The reason that that works is, as you guys might have heard in my last video, acids and an alkaline substance, when mixed together, have a reaction. But because he stopped the reaction with having the smoke, the actual gas that's produced by the mixture actually puts out flames because it takes away the oxygen. It's kind of like a suction, like mercury catching air before for like a suction device. The way that that works is, if you've ever seen a tutorial for certain things, I don't know what it is. Again, it takes me a second to think about this. Basically, if you so imagine those clothes or paper towels or whatever as sort of like a pipe that can be bended, like a rubber pipe sort of thing. If you fill it up with water, keep one side in the water and put one side over like the wall or whatever's containing the water will actually keep flowing until the water out there is the same height as the water in there. It's the same principle here. The way that that works is heat rises, cool, just kind of stays because the the hot molecules are trying to bounce around and spread out more. Since they have more energy, they try and go to the top. Hang on, everyone, for like 2 seconds. Sorry about that, guys. So anyway, the way that this works is it's the same principle as earlier. The salt, because it has more density and mass in the water, actually makes it so the egg has less density and floats. Same as the sugar one that we did earlier. So the way that that works is basically when the air bubbles from that, hang on, the air bubbles from that would actually lift it up because of all the carbonation. The air will actually be pushing it up while the water would stay at the bottom. That's how carbonation works, because the air molecules that are basically pushed into it keep coming up because they keep forming, because of the amount of water in comparison to the amount of oxygen in comparison to the water in the jar, which makes it so that those are lifted up because of the density difference. Now, we've talked about this a lot. Water has a higher density than oil, which means it'll actually go below the oil because it has less mass. And with the food coloring, how it stayed in a sphere for a good amount of time, because it is part water, it does have water-like textures, so it has that surface tension, and it still will have a reaction to, or it will not have a reaction to oil, but since it's not fully water and it has other things mixed into it, other compounds, it basically becomes mixed if you mix it. By the way, a compound is a mix of two elements or more. And the way that that works is basically the food coloring from the oil is seeping down because of the density difference. I'm going from speculation here because I don't know what he was using, but it seems like he was using soap and what seemed to be like a magnet or something like that. And I think the reason that that works is because of the magnetic field and water having water having minerals in it, and water being a big component of soap. I think that that's how that works. Again, I don't know the resources that he had, so it could actually be different. The way that this works is the hot water is actually blowing the gas. So hot water always wants to rise. We've talked about this a few times. But the cold water just stays still and it takes the hot water out. Because heat can never be destroyed, only transferred, the heat is transferred into the cold water source here and taken out of the bottle. But when it's put back in the heat, the heat rises, turns into a gas or something like that, or heats up the gas inside the bottle and makes it so it basically expands the balloon. The cold water then stops that effect by taking away the heat. I know that we've kind of already done this one before, so this is kind of annoying. But, yes, it's because of the suction and tension on the actual...
3 o'clock.
Thank you, random computer that I built. Anyway, the suction on the actual cap, or gauze, or whatever he was using, and tension is enough to stop the water, but only for a certain amount of time. That's why he had to flip it over so quickly. Because if it had stayed that way for, let's say, 14 more seconds, it probably would have broken or seeped through. This is the rubbery egg trick. I'm just thinking that, maybe. What happens is vinegar has an acidic effect. So basically what it does is it takes all the air and basically the brittleness of the actual shell, and it converts it into a rubbery-like substance using different molecules. So, like, it's a very acidic substance. It meets a very base, not an alkaline substance, just in the middle, base, like milk or water or something like that. And basically when those two react, instead of forming a big explosion or anything, given time, it gets rid of brittleness because of the acidic stuff. So basically, it melts away part of the layer of the shell and makes it so the shell becomes the inside. I don't know if that makes sense. It's just a weird version that I'm saying, so hopefully you guys understand it. Sap powder is kind of like fake ice. So what happens is if you add water, it rises, it becomes colder, and it basically looks like snow and ice, and it's meant to look like that. So you add the powder. Basically, that's not a very hard one. If you want me to tell you how to do it, put it in the comments below, and I will totally explain it in the next video before I do anything. The reason that that happens is, as you can see the orange right here, it has a thick coating of the orange peel, which means no water can get in, which means there is air still trapped inside of the orange, just in between the layer of skin and the actual orange part. But since he took the skin off the orange down here, the water can actually soak in, and as you can see, there's some bubbles and stuff coming off of it. That is the air coming out of it, basically meaning that this has a higher surface tension in general, and this is just basically a fill-up of water. We already saw this in the last video. If you haven't watched it, go watch it. I'll explain how to do it there. So this video isn't sponsored, but if someone wants to sponsor any of my videos, I'd be happy for that. Although that's why I'm not really playing the ads. That was just a trick. There's no science in that. That's just a trick. Again, we also discussed this in the last video. The reason that it happens is because of the suction and all the pressure on the actual bag. and because of the pencils that are actually just filling up the hole, the water can't escape. But yes, if you take them out, the holes are uncovered and it can just go out. The reason that that works is oil responds differently to different things, and I believe that that's what he's using. And because of the byproducts in toothpicks, they actually, wax that is on them has a decent amount of water in it, oddly enough, even though it reflects water like oil. It responds differently to oil, so it will actually move that. But I don't think that that's it. I think the reason that that's happening is it's seeping into the actual toothpicks and moving them because it's trying to expand. Because the toothpicks are a solid and the oil or water or whatever he's using is a liquid. It is trying to expand because it's basically a less active gas and a more active solid. So the solids are basically just in its way, blocking it. So any way that it can find to escape, like these cracks, would be a way that it would go. That would be my theory. I'm not completely sure about that. The way that that works is basically the water kind of goes through both pages, making it so they basically merge into one. It's not much of a theory, it's just that's how it works. It basically just makes them into one, and the colors spread through to the top because they get wet and they become easier to move. That's basically all that happens. It's not very exciting. Except it does look pretty cool, I guess. Actually, many people don't know this, and I got this in a comment from one of my actual gaming videos. Because, well, not my gaming videos. I got this as a comment on one of my, basically, I have a ton of other, stuff that I do. Image flip, scratch, a ton of other things. But I posted a video of me doing this, and me saying that ink and markers actually are just a thin layer of basically a thin layer of solid. Nobody believed me. So I want you guys to go tell your friends and show them this video because nobody understands. An actual pen and markers usually are just a thin layer of solid that they create. It's not like color. It's just an actual solid thing. It's just a very, very thin layer. And if you were to touch it, it would probably shatter. See, this is what I'm talking about. If you add water, it'll come off whatever you drew it on. Now, depending on the marker, it could be a certain marker that basically makes it so it's like it just goes away. The way that that works, if we go back, this is a theory that a lot of people have made. As you guys can see on this side, it would actually have more space than this. Because the water is actually dragging it down because of the stickiness and surface tension of the water, it would make it so this Lego cube, which I'd roughly say weighs 1, maybe 2 ounces, the water would actually pull it down, so it would ensure about 1.5 ounces. But this guy was smart enough to make it so the pink, whatever the plastic thing he's using, isn't half and half. It's more towards the water side, so that this can get more gravitational pull because of the water tension pulling it down. And basically, it's the seesaw effect. If you take one object that's closer to the middle of the seesaw, it won't weigh as much if the same thing is on the edge on the other side. It's the same thing, except it's just a much smaller size. We saw this in the last video. You guys know how it turns out. It gets a silvery, cool thingy. I don't actually know if I showed you that. Although, basically what happens is it gets a silvery texture. And what happens is the water molecules actually go around every part of this entire egg that's underwater. It's just when you put black underwater, it kind of looks silvery because it basically gets everything that goes underwater has a thin, like very, very thin layer of water that goes around it. And that's what's reflecting off of the egg right here. Okay, I'm not going to explain this again because this is the thing that we've gone over many times. So I'm not going to explain that. Watch the earlier part of this video or watch the first video because I've explained it now twice. Sorry, I get a little annoyed about that when I have to explain something so many times. We watched this also. Maybe we didn't. This might have been me on my own time. What happens here is, as you can see, as he twists the bottle on, the air pressure, when it's put back on, this little air pocket basically pushes down on the water, making it squeeze out. But if he releases it, there's no air pressure. The air can just release quickly because air rises or heat rises or whatever. And because gases are more heated than liquids, the heat would actually be trying to expand, so it would also be trying to expand downward, pushing the water out. This is the varying layers of density. We've gone over this maybe a little bit, but the varying densities are basically, honey is very viscous. That means it has a lot of density and less water. But the food coloring, or wait, what did he use? I don't know what he used. He used, hang on, water and color. So he used food coloring and water. Water would be in between oil because it doesn't react with oil. But because oil is very, very light and not a lot of, and doesn't have a lot of density, it's very unviscous. But honey is very viscous, which means it has a very high density for liquid. Water is in the middle, and then those solid objects that he added are just to show how dense each of them are in comparison to a solid thing. I have a feeling that this is going to be the reaction between a acid and an alkaline substance, and I am correct. Like I said in the last video, baking soda and vinegar, when put together, expand. But as we've seen, it can also expand upward to make a gas, because that's trying to expand and make it so that it can escape, because heat wants to rise, and because of the reaction, it creates a lot of gas. which means it heats up, and it goes into the balloon and is captured, but it just stays there because of it trying to expand. So it really wants to just expand upward because it's technically a little bit more hot than the other parts of the other water and vinegar and baking soda parts of that. The way that that works is the heat kind of steam is like a actually has a decent amount of water, and because fire never wants to be without air and it needs air to actually be produced, it will do it won't like do anything, but it'll actually melt the outside of the egg, making it so it'll actually slip through because it'll make it so it has more condensation because of the gas turning into liquid on the egg, which means it'll actually become more slippery and it would slip through. The way that that works is when an acid interferes with a rubbery sort of object like a balloon filled with air, it immediately has a reaction with the actual substance. I don't know what it is, just specifically with balloons. That's what I've seen. I'm kind of left in the dark here because I haven't actually done a lot of research on that. But from what I understand, it seems as if the acid melts it to a point so that the air just tries to escape while the acid's trying to help it escape, basically. The way that this works is water always wants to take the shape of whatever it's in. So, if you basically do this experiment at home, which I'm not saying that you should, although this video, ignore the name of the video. I'm saying probably maybe don't do this at home specifically. If you do this, you would see that because this floats, if you put a cup down, the water will go under and trying to occupy the space in the cup rather than the bowl itself because it wants to fill up every single part of the thing that it's in. And as you saw for a second there, it just stood there. And that's just because of the surface tension and the suction. So I hope you guys enjoyed the video. Have a good time. Remember to subscribe, not to this guy, but, well, you can subscribe to this guy, but also sub to me if you can. If you want some cool gaming videos, go to my regular channel, link in the description below. And see you guys later.